We now discuss the solution of a problem from the section Permutations and Combinations. The given question is on the enumeration or the counting process. This question has appeared in the joint entrance examination main held on 26th June 2022 in the session 1. The given question is, let A be the set consisting of all those natural numbers n belongs to capital N, where n stands for natural numbers, such that the HCF of n comma 45 is equal to 1, and let B is equal to the set consisting of 2k, where k belongs to the set consisting of 1, 2, 3 up to 100. Then the sum of the elements of A intersection B is, we are given the set A is the set n belongs to n such that the GCD of n comma 45 is 1. That means A consisting of all those natural numbers which are relatively prime to 45. Let B be the set of all even natural numbers from 1 to 100. Even natural numbers 1 to 200. 2k, k belongs to the set consisting of 1 to 100, means set of all those even natural numbers 2, 3, 4 up to 200. Required to find the sum of the elements of A intersection B. That's our given question. Let's now discuss the solution of the problem in detail. We have the set consisting of n belongs to the set of natural numbers such that the HCF of n comma 45 is equal to 1. First note that 45 is 3 square into 5. This is the prime factorization of 45. And B is given as the set consisting of 2k, k belongs to 1, 2 up to 100. That means B is precisely the set consisting of 2, 4, 6, etc. 200. Now A intersection B is equal to the set of all 2k, because the intersection we are taking, set consisting of 2k such that 2k comma 45 is 1, where k is equal to 1, 2, 3 up to 100. Now how do we enumerate this one? So to do this one, first take B, capital B, from that subtract minus all those 2k's where k belongs to 1, 2, 3 up to 100, such that 2k is not relatively prime to 45. That is, the GCD of 2k, 45 is not 1. So from B, subtract this set. So that is equal to B minus the set consisting of 2k such that the GCD 2k comma 45 is not equal to 1. HCF and GCD are one and the same, where k is equal to 1, 2, 3 up to 100. The GCD normally denoted by A comma B if we write the GCD of A and B. Now let A6 is equal to the set of all 2k, k is equal to 3, 6, 9, 99. Now that means that this is the set precisely consisting of multiples of 6. that is 6, 12, 18, 198 up to, so all those multiples of 6 from 1 to 2 to 200. Agreed. So if you observe that, now each element of A6 you take and take the GCD with 45, then you will get it is either 3 or 9. Therefore, the GCD is not equal to 1, that is HCF is not equal to 1. Now, let A10 is equal to 2K, K is equal to 5, 10, 15 up to 100. Then the set is the set consisting of 10, 20, 30, etc. up to 200. And if you take any element of A10, take its HCF with 45, then it is either, you get a 5, GCD as 5 or 15. So now let A15 is the set consisting of 2K, K is equal to 15, 30, 45, etc. 90. The set consisting of 30, 60, 90, etc. 180. And if you take any element of A15 and take its GCD with 45, it is 15, which is not equal to 1. So these are the ones, these are the elements. Now when you take the GCD with 45, it is not equal to 1. So note that M, 45, the GCD of M and 45 is not 1 for all M belong to A6 union A10. Now what about A15? So the A15, each element of A15 is present both in A6 and A10. So both in A6 and A10. In A6, the elements of A15 are there. In A10, the elements of A15 are also there in that A10. So now from B, we have subtracted a set. That set is the set 2K, the GCD of 2K, 45 not equal to 1. K is equal to 1 to 100. This will be precisely A6 union A10. But this A15 is appearing both in A6 and A10. That means the number of the elements of A15 are enumerated both in A6 and A10. But in an enumeration, you have to enumerate only once. Therefore, the excess, that is one time enumeration, is an excess in this case. Therefore, subtract that one. So A6 union A10 minus A15, that will be precisely the set 2K, where the GCD of 2K with 45 is not equal to 1, for K is equal to 1 to 100. So B we know, and this set 2K, where 2K, the GCD of 2K with 45 not equal to 1, all that set also known to us. We continue in the next slide. So that's what precisely we have done it. So A intersection B is B minus the set A6 union A10 minus A15. Agreed. Now the sum of the elements of A intersection B will be, see here, the sum of the elements of B, this is the one, that is sigma x, where x belongs to B, sum of the elements of B, minus the sum of the elements of A6, yes, minus the sum of the elements of A10, minus into minus, plus the sum of the elements of A15, minus into minus, plus sum of the elements in A15. So the sum of the elements in B is the first one, 2 plus 4 plus 200, minus sum of the elements of A6 is 6 plus 12 plus etc. plus 198, minus the sum of the elements of A10 is 10 plus 20 plus so on and so forth plus 200, plus sum of the elements in A15, that is 30 plus 60 plus etc. plus 180. Agreed. In the first one, the multiples of 2. So take 2 common, 2 times 1 plus 2 plus up to 100. In the second one, take 6 common, minus 6 times 1 plus 2 plus etc. 33. Minus, in the third bracket, you take a 10 common, 10 times 1 plus 2 plus so on and so forth plus 20 plus, in the last bracket, 30 times 1 plus 2 plus etc. 6. So 1 plus 2 plus etc. up to 100 is the sum of the first 100 natural numbers. Recall the formula. The sum of the first n natural numbers is n into n plus 1 by 2. So in this case, 2 into 100 into 101 by 2. Here minus 6 into sum of the first 33 natural numbers. 6 minus 6 into 33 into 34 by 2. Here minus 10 into 20 into 21 by 2 plus 30 into 6 into 7 by 2. So those are the things what we have written. And multiplication we have done and simplified. The first one is 10,100 minus the second one is 3,366 minus the third one is 2,100 and the fourth one is 630. When you add all these things, you get 5,264. Therefore, the sum of the elements of A in section B is 5,264. So that is the detailed discussion of the solution of the problem, which is on counting and enumeration. So it's an enumeration problem from the section permutations and combinations. I am sure that you have understood the solution of this problem. I wish you all the best. Thank you.